Hello and welcome to the Human in the Machine podcast, the podcast about all things HCI. As ever, I'm your host, Professor Ben Cowan. In this episode, we're joined by Dr Hannah Pelikan from Liköping University in Sweden. Hannah is an expert in human-robot communication, and we were lucky enough to have her join us as part of our regular HCI seminar series here in Dublin, where Hannah talked to us about sound design in human-robot interaction. So we managed to grab a recording of the talk, and with Hannah's permission, we put together an episode for your listening pleasure. Again, if you like the podcast, please don't forget to review and follow us. And if you want to get in touch with us, you can by emailing us at humaninthemachinepodcast@gmail.com. But without further ado, please sit back and enjoy Hannah's talk.
So yeah, I thought I'd start with a little story. So this is Ben Gabalden. He is a audio designer who used to be the lead audio for Cosmo, the Cosmo toy robot, which you will see in a second. It's a small robot that was kind of designed as a sort of like quite minimal robot that is controlled through your phone and then sort of like goes off and can play games. It doesn't really talk. It can sort of like read out like text to speech, but it doesn't really speak. So that's the whole design. So audio was really important. And I spoke to Ben, and we had him also at a workshop, and it was quite interesting to learn about how he went about like doing these very advanced sound designs. And one of the things that he did, for instance, is design an animation that was supposed to indicate that the robot was happy. So at the end of a sort of face recognition sequence where the robot is scanning your face, the robot would then end by playing this, by saying your name and then playing this animation. I'm just going to play this video very quickly for you. So you can kind of see it's a small animation with the robot lifting its forklift arms and then playing this sort of squeaky sound while displaying some sort of happy, smiley eyes. And something that really struck me is sort of when I went into family homes and took Cosmo with me and looked at how people play with this robot, I found that even though this is designed to mean happy to see you, that's not really how it always gets interpreted and how it works when you put it in these contexts. And here I brought you a video clip of a family, or sort of like two adults who were in a family home. They are attending a dinner party and they're waiting for the other people to arrive. In the meantime, they're playing with a robot. And we have them here with Cosmo behind this beer bottle, looking at the man here, Ulrich. And the robot is in the process of scanning his face, and it takes quite some while. So he's kind of like actually getting a bit impatient, and then offers the robot beer. He asks, do you like the local beer? So he says in German, you will hear it in a second, magst du Giesinger Bier? So he's offering the beer. And at that moment, Cosmo is playing this happy to meet you animation. And as we will see, this then gets interpreted as full agreement. Cosmo likes the beer. So he says, volle Zustimmung. And then there's a lot of laughter, as you will hear. So I'm sure even if you don't speak German, you will be able to really kind of get the vibe of how this happiness animation gets interpreted as Cosmo liking the beer.
Magst du Giesinger Bier? Ah ja. Volle Zustimmung.
Ja, man schlägt es sich ja gleich.
Willst du einen Schluck trinken?
So at the end here, he goes even on and offers a sip of the beer to the robot. So we see that this animation is not only sort of like interpreted quite differently, but that it also kind of like leads to a different sort of like trajectory of the interaction. Like this is no longer about the face at all, but they will now proceed to try and feed the robot beer, which is of course slightly problematic because it's a plastic object that could easily break if they really go on and like dip it into the beer. So I was actually quite worried when I was there. So seeing examples like this, like really got me wondering sort of like, okay, so we have a very advanced sound design and we put a lot of effort into making a sound to me sort of like a certain thing. And then we go to the wild, we take the robot into the settings that it's supposed to be in, and it doesn't really work. People interpret it in different ways. So I was wondering sort of like, what can we do about that? And this is basically like how I ended up sort of like writing my entire PhD thesis. I put a little QR code here if you want to have a look at the PDF. And in the thesis, I worked with actually 3 different robots: a small toy robot, the Cosmo robot, a quite large autonomous bus that you can step into, and then more experimentally also with a more kind of vocally oriented robot that was supposed to be in team interaction. So that had more sort of like verbal interactions, and we were looking at sort of back channeling behavior. So you can see sort of like how, for me, robots can be in all kinds of forms or shapes. I think the important thing is that you can interact with them. And of course, work in academia is never done just by yourself, but I had wonderful colleagues on this project, most notably my advisor, Lilo Kevelik, who was hosting this non-lexical vocalizations project, which actually studied mostly human-human interaction, looking at how so-called non-lexical vocalization sounds are part of human language, how we use them to coordinate with people. So I could kind of build on this very, very new research that is emerging now, that is teaching us that all these oops and ouches and when we taste some good food, that these are also part of language, and that they're not just some sort of weird stutters or garbage that mostly large language models are still unable to produce, but that these are actually really important functional parts also of language, spoken everyday language. So I was trying to like draw on these insights that the team came forward with, and of course other researchers that are doing similar research, and to translate them to robots. And as you've seen, like sort of like working with all kinds of different robots, the idea is not to sort of like copy exactly how a human does it and then put that sound file on a robot, but rather to understand what kind of like function do these sounds take in interaction, and can we achieve something similar by putting sound on a robot. So I developed this framework for designing sound and interaction, where I have 3 steps basically to really kind of go through a process that is grounded in interaction, that I don't just sort of like work with a sound, but that I can actually kind of start from actually observing interaction. I call this phase describe, where I go and do video analysis, look at video snippets with others at data sessions, and then sort of like go to a stage that I call intervene, where it's really about designing sound. And this is sort of like quite exciting, I find, because really going between sort of describing interaction and then doing something that is more active, but grounded in the interaction is something that hasn't really been done before. And then finally, I have the reflect stage, where you kind of feed back into this sort of like loop that you can actually start again by kind of recording what you're doing with the sounds and trying to analyze and see what happens and how they change the interaction. So here I will really go in and transcribe video clips and do interaction analysis to understand, maybe also collect similar clips, and to really kind of also academically sort of try and understand sort of like how does this change maybe what a robot does, the interaction. So I thought I'd give you a bit of a background on robot sound before sort of like talking a bit more about this framework. Sound and human-robot interaction is quite broad, actually. It's sort of a really exciting area, because I think we are so focused on visual aspects that we've been looking maybe a lot of at sort of how robots actually look like, but then they are never silent, right? They have motors and they kind of produce sounds even when they just move a little bit. So even those so-called consequential sounds are an important part of a robot's presence. And then on the other end, sort of like we might have intentional sounds that are really kind of put there by designers like Ben, who sort of design deliberately, like, and very carefully sounds that are maybe closer to back channels, or we might have sort of such so-called vocables or effect bursts, very emotional often. In human-computer interaction, we have earcons and auditory icons, where we really work sort of with the sounds that can convey meaning, either sort of like through some sort of beep structure or by copying sounds from the environment. So we really have all kinds of sort of like sounds, and I want to put them on a spectrum a little bit. We can maybe kind of put the motor sounds on one end and sort of sounds that are more closer to vocal sounds on the other side. What's interesting is that for human-robot interaction, mostly we've kind of been thinking about sound in a way that we kind of ask, what does a sound mean? And this comes a bit also from product design. You might kind of know these studies for cars, like, oh, does it sound sort of like expensive or more sort of like angry maybe? So there has been this sort of like idea that a sound means something. So a lot of these studies that have been done before in HRI were focusing on playing a little sound snippet and then asking people, mostly sort of like even with a drop-down list, was this happy, angry, sad, and so on. And what I'm trying to sort of like show in my work is that that's not really, like, you can do that, but you should do it later. Before you can do that, you actually need to think about, like, what should the robot do with this sound? And the other aspect of robot sound design is that usually, and this also again comes from a more like product design perspective partially, is that a lot of sound design happens actually in studios or laboratories, often sort of like soundproofed rooms actually. And outside of concrete interactions, you will see that a lot of like robot sound studies actually don't involve a real robot, but it's just a video snippet or just maybe only audio. So we don't really know actually how sound is understood in the wild and how people perceive it when we are kind of in these environments where we then put robots. And I want to look at this quote that I brought by Nick Enfield. He's a linguistic anthropologist, and he's reciting a very famous conversation analysis person, Harvey Sachs here, who sadly died in an accident, so not a lot of his work is actually published by himself. But he sort of says here, if we try to imagine interaction, we often imagine things that rarely happen, or conversely, we fail to imagine things that actually happen all the time. So he's really putting focus on that we can't just sort of like make up sort of like, oh, this is how it's going to be like, but we need to kind of go and study what actually happens. So this is an interactionist view, as I call it, where maybe several sort of like approaches can be subsumed under that view, but sort of the perspective is really that meaning is co-constructed in interaction. So we don't sort of like have one person who says like, this is what I mean, and then you have to sort of like correctly or wrongly decode it, but it's really something that kind of happens together. Like if I say something and you kind of like hear it in a certain way, you can kind of like in your response show how you understood it, and then I can kind of like come back and say, oh, that wasn't really what I meant, and so on. So it's really seen as a kind of process that happens together. And then also very importantly, utterances are seen as having meaning potentials. So any sort of like vocalizations are really kind of semantically underspecified. And I think this is specifically important for sound, that we don't have sort of these fixed meanings. We can't say this means I'm happy to meet you. It can mean that, but it can also mean I like beer, right? So you see already that the potential meanings may be kind of like towards something that is more positive, but we can't really say it means X. And then interaction is seen always as multimodal. So we can't really think in channels, but we need to sort of like see how things work together, how the voice is kind of connected to the body, for instance. And specifically, like my work is kind of from an ethnomethodology and conversation analysis perspective. So we're kind of really trying to study moment by moment how social order emerges in mostly like naturally occurring interaction. And the way I work, I think you've maybe noticed already, like I do a lot of video recordings and then I transcribe them and analyze them together with others. So how do we bring this view into sound design? Because I think this is really like a lot of insights that we can bring and combine with interaction design to design better sound for robots. And in the remaining time, I think I will go a little bit about through the study that I did with the shuttle buses, because I think here you can kind of see also how a lot of these things that come from social interaction that we can maybe imagine on a robot that is more like a human, how they can even work on a very, very kind of mechanic system like these autonomous buses. So here you can see how they look like. It's kind of like a small shuttle with space for, I think, 8 people who can sit down, and then a couple more who can stand. And these buses usually have a safety driver. Like in Sweden, this is kind of like legally required that you have to have someone who's always monitoring that everything is going all right, but they are basically self-driving, so they will not they don't really need intervention except for maybe some specific sort of crossings where it's pre-programmed that you need to press a button to advance. And the way that they work is that they basically go on a pre-programmed route. So they're kind of like a tram, except that you don't have the tracks. So that's also like nice that you don't need to actually put the tracks here, but you can just put in the route and then they can go to a new neighborhood. And I should say that what I'm going to tell you now is published in an HRI paper that was also nominated for a Best Paper Design Award. So I've been following that project for quite a while, like 2.5 years. Did quite a lot of video recordings and rides with the safety drivers, interviewed them, of course, on these rides, and also talked to the sales director at one of the companies, one of the project coordinators at the local transport provider, because it's, of course, quite a large project with different stakeholders involved. And then I also presented like my ongoing work to these stakeholders. So I want to walk you through this sort of framework that I talked about before, where I have describe, intervene, and reflect, and kind of show you how each of these stages can look like. So first of all, when I went there and sort of like did observations and video analysis, I noticed very early on that there is I noticed quite early on that there's quite a lot of problems on the road because these shuttle buses stop quite a bit when cyclists get close to them. And I just want to play you a video where you can hear also what happens when the bus is stopping. Vi kanske skulle kunna göra en anpassad, vi kanske inte ens behöver vara med på det seminariet om material. Vi kan ta ner själva själva teorin om ramen och själva laddbiten. So maybe you heard it there, ding, like there's a cyclist getting too close and then the bus is sort of stopping. And if you kind of watch carefully, you can see how the cyclist is just continuing, doesn't even really turn very much, and the bus is stopped there for several seconds. And this is something that keeps happening, like, and it's really annoying for the people who are on the bus. And something that then struck me when I looked further is that actually you could kind of like say, well, okay, the sensors detect someone, it's a problem, but the safety drivers, they know far like earlier that something like this is going to happen. So I had like often cases where the safety drivers would actually warn me. So here in this case, we would sort of like go on a bit of the campus, and the safety driver would then sort of say, let's see how the bus reacts to these here. And there was some sort of like oncoming cyclists. And you can kind of see in these pictures that I have here, sort of like how he even moves a little bit his foot to like stabilize himself further, so that if the impact is coming, he will not fall. And he can then sort of like even announce like, now the brake is coming. So there's a lot of time passing before the bus actually stops, and the safety driver is sort of like there doing nothing. But they could, of course, if they were like driving themselves, sort of like adjust, right? So I think it's quite interesting that from a human perspective, we can already anticipate, okay, here's something that is going to be problematic. So it's not sort of like unexpected and random. So I was seeing an opportunity here to actually come in and design something that would help the bus to sort of like communicate to the people, to the oncoming cyclists. I cannot move. I will kind of end up braking. So then I went to this stage where I actually, from my video analysis, found ways to intervene and to kind of work with different methods for sound design. And it's quite interesting because sort of like from a more sort of like research philosophy perspective, also, of course, like how do we work? Like sort of like the descriptive methods are very much grounded in like just trying to focus on the understanding that we have there, like very kind of empirical analytic. And then in this intervene stage, I needed to take quite a different stance. And I took a research to design approach where I didn't really kind of aim maybe necessarily to have a final product that I could then deliver to the company, but really rather to think sort of like in a very different way about sort of future ways of how this could go, the interaction, right? So I'm no longer interested in understanding in depth what is going on the road, but now I want to think sort of like what could happen? What can I do with the sound on the road? How can robots interact better with people? And rather sort of like think very broadly and brainstorm different options. So I drew on the existing methods for rapid prototyping and sound prototyping, such as embodied improvisation, video prototyping, vocal sketching, which is quite a fun way of working with sound, where you basically use your own voice to test out different ways of sounding. And then also sonic overlays, which is something that you maybe often see in videos where somebody has sort of like a robot or some sort of machine, and then there's some sound that is just put over it to sort of show how it could sound. And one of the really important things that I found is that you can't just start in many settings and just kind of produce sounds. And even in this non-lexical vocalizations projects, we found that it took us quite a while to be comfortable just sitting there in a research environment in a conference room and to imitate strain grunts and all kinds of weird sounds that we are actually taught not to produce in a professional environment, right? Like very early on, we're told not to burp, not to kind of produce any body sounds. So in order to kind of like make sounds with our voice that are not sort of like verbal speech, we need some sort of like way to get into that mode. So I developed a game that is called Sound Ball, where you kind of like throw a sound around. So like you have an imaginary ball, and while you throw that to your partner, you produce a sound that it could be a syllable like that you just say ma, and then the other person is catching that and will kind of repeat that before then creating a new sound and throwing that to someone else. And I found that even though it's very simple, is a really good way to warm up and to become comfortable with using sound. And my students also use this now and said like, yeah, this is very helpful when you have some sort of like co-design session as well. And then another kind of way of using the sound that I found really, really helpful and that builds on this previous stage of observing is to use short video clips that I used, that I found sort of like useful in understanding what is going on for the actual design process. So I would kind of take a clip that I had and that I would normally show to present an analysis and to say, well, here you see that something is happening, and then make a voiceover on this clip, and not only one sort of like as a kind of final product, like this is how it will sound, but rather kind of to do that over and over and over again to practice and to test how will this sound, when do I need to play the sound. And I just want to play you like a very short original clip where you will hear the kind of existing sounds on the bus when it brakes, when a cyclist is trying to squeeze past. And then in the second round, you will hear one of the voiceover rounds that I did, where you hear kind of like sounds that precede this moment where the bus is braking. So when you hear the ding ding, that's when the bus is actually stopping. So it's too late. Like the cyclist has no way of knowing, okay, this bus is going to stop now. And the sound then is more sort of like a kind of past the event, like ding ding, I stopped. Well, okay, that's obvious. So now let's hear how it sounds with the voiceover. So of course I can't alter like the video clip. So that will stay the same and the bus is still braking, but you can kind of hear how the sound could be timed, especially because when we work with sound, one easy way to start working with sound is just to go online and to search some sound database and download some sample sounds and then play them. But the problem is that I found for interaction, they're often far too long. You will get sounds that are like 30 seconds, and that's too long, simply. Like it usually doesn't really work. So kind of working with the precision timing was very helpful in understanding, okay, how long does my snippet need to be and what kind of sounds can I use? And you also get a bit of the environment of the sound. Like ideally you go to the actual places where you will play the sounds to kind of listen, do they work? But the video can already provide you with a bit of a kind of sense of, will this sound be noticeable even in this specific setting? And then finally, I actually put a speaker, like a Bluetooth speaker, on the bus and connected it to an app that allowed me to play sounds on a button press, and then acted in a kind of Wizard of Oz manner where I could then play sounds while the bus was driving. And in the beginning, it was mostly me doing that, but then eventually I also got the trust of one of the safety drivers, who then said like, oh, this is actually exciting. I will try that as well. So in this clip that I will play you, he is actually using some sort of handbell-like sound. It's electronic, but he kind of shakes the phone. And whenever he shakes, there will be some sort of like ding, ding, ding sound. And as the bus is approaching a group of pedestrians, he then uses that sound to make them move to the side. And you will hear also that the bus here is not actually braking in the way that we heard before with this ding ding, but that is actually managing very slowly, but it manages to pass the group as they are stepping away. So basically the sound works as some sort of like request that they should move, but they move in different ways. So I'll just play it to you. So it's a short clip. So it's a short clip, and you can hear that the sound is very simple, but you will hear that it's also repeated in an interesting way. And sort of like, maybe you can hear that there's a bit of a kind of faster and then slower. And when I then went to my reflect stage, where I actually go and analyze this clip in detail to understand not only, well, it worked great, but sort of why did it work and what happens actually, then I could see how the bus driver is adjusting, of course, to the group, and how they treat sort of these sounds as instructions to do different things, right? One person might actually just turn around. Another person is then sort of like starting to walk backwards, and then sort of someone else is walking sort of like forward, and they kind of find their own ways of reacting to that sound. But it's quite interesting to sort of see how you can use repetition here as a tool to kind of keep indicating, okay, there's something that is still not right. Again, this was the example of buses, but the method can be, of course, applied to other robots as well. And I've also looked quite a bit at the timing of sounds, especially with the Cosmo robot, where I looked at, for instance, how the robot can manage delay, sort of like when it's processing, by playing more sort of like machinic sounds, actually, and how to also play sounds that can kind of draw back the attention to the ongoing activity. So there's a lot of sort of things to look into, and I think I want to stop here and just summarize. Sound is interpreted in interactional contexts. So what I said before about sort of like sound being semantically underspecified is really sort of, we cannot say in advance as a designer, this is what it's going to mean. We need to sort of like have this flexibility and work with this as an asset also, because I think this is exactly where sound can come in, that we sometimes have contexts where we cannot sort of have a sort of like phrasing, like if Cosmo had said in the beer example, happy to meet you, that it would have been a completely kind of misplaced, out of place response to a question about like, do you like beer? But kind of using sound can also in that sense be sort of like a resource, but we need to keep in mind that we cannot fix sort of like a meaning. Another really important lesson that I want you to take from this is sort of like that sound is multimodal. We need to work with our bodies. We can't just sort of like click sound samples on a computer, but to really understand sound interaction, we need to get up from our desks and to also start moving when we work with sounds. And then finally, there are really interesting functions that we can use sound for. and combining this methodologic conversation analytic video analysis with interaction design in the framework that I showed you, where you have sort of like different steps of describing, intervening, and reflecting, can be a great way of working with like sound for interaction.
Giving a robot beer. Love it. But also agree, quite dangerous. Thanks very much, Hannah, for that. That's a brilliant talk. Again, don't forget to review us and follow us. And if you want to get in contact with us, you can by emailing us at humaninthemachinepodcast@gmail.com. But as ever, all that's left for me to say is I've been Ben Cowan. Stay curious and don't let the machines get you down. Until next time.